Hi students, I'll try in this educational video to technologically introduce the steel beam resistance under the bending ultimate limit state criterion, of course as simply and as clearly as possible. Okay, let's go. Well, the bending ultimate limit state criterion is expressed by the Eurocode 3 standards associated to the European standards 1993 as MED divided by MCRD lower than 1. This means that the MED, which is the design bending moment, should be lower than the MCRD, which is the cross-sectional bending moment resistance. So the design bending moment MED can be simply seen as the maximum bending moment applied on the beam, which is determined based on the BMD, the bending moment diagram, depending on the load case as it is depicted by the table that you see now in this slide. So BMD is the bending moment diagram and SFD is the shear force diagram, and these two diagrams depend on the load case applied on the beam. For example, here in the first load case, we have a beam with a length L supported by two hinges in its extremities A and B and subjected to a linear distributed load Q. The maximum bending moment will be equal to Q multiplied by L square divided by 8. The other load cases are expressed by this table and also other tables for other more complicated load cases. Now for the cross-sectional bending moment resistance MCRT, it's determined based on the table that you see now in the slide. As you can see, MCRD depends on the class of the cross-section, and here you can notice that for the class 1 and 2 we use the plastic section modulus, and as I explained in the previous video, the cross sections class 1 and class 2 are characterized by their plastic behavior when they are subjected to bending moment. For the cross section class 3, we use the elastic section modulus, and I explained in the previous video also the elastic behavior of the cross sections class 3. And for the cross section class 4, the effective properties shall be used, and we use the effective elastic section modulus in order to determine the bending moment resistance. So for the cross sections class 1 and 2, the cross-sectional bending moment resistance MCRD is equal to MPLRD, of course PL here to say plastic, which is equal to the plastic section modulus multiplied by the steel yield stress divided by gamma M0, and gamma M0 is equal to 1 in this case. For the cross-section class 3, the cross-sectional bending moment resistance is equal to MELRD, of course EL here to say elastic, which is equal to the elastic section modulus multiplied by the steel yield stress divided by gamma M0, which is equal to 1. And for the cross-section class 4, the cross-sectional bending moment resistance is equal to the effective elastic section modulus multiplied by the steel yield stress divided by gamma M0 equal to 1. This is how we can determine the cross-sectional bending moment resistance for the different classes of cross-section. It's to note that the elastic and plastic modulus of steel beam cross-sections can be found in any table presenting the design properties of steel profiles, like the one that you see now in this slide. This table presents the design properties of HEA profiles, uh, and as you can notice, we have the elastic and plastic section modulus about major axis and minor axis of the cross section. Also, For the steel yield stress, it's provided by any table presenting the mechanical properties of the steel grade. For example, here, the table that you see now in this slide, you can notice on it the minimum yield strength for different steel grade and also for different nominal thickness. That's all for this educational video. Please, if you have any remarks or suggestions or questions, please mention it in the comments. Thank you very much for your attention.